Good day. This is actually my Capstone project too. And for this project, I was actually curious about machine learning and wanted to implement like some of the things I've learned so far in the course of the year. So I'm using one of the project dataset links. I stumbled on a data set for predicting the comprehensive strength of concrete. And so for this particular model, I wanted to like try out like linear regression, lasso ridge, just to be able to like see which model was actually um was going to like give the best output and also like accuracy in terms of like predicting the strength of concrete. And so the first step was to just examine the data set, which you can actually see. So that's then for these like one, two, three, four, five, six, seven, eight, nine. So nine features. Um then I also wanted to like find out if we had um null values. So as you can see, that's actually zero. Then I also used describe just to find like the distribution, such as like the maximum, the minimum for like each feature, and also the mean. Then the next step was to drop the duplicates because I didn't want it to skew my prediction output and accuracy. So done. And then I plotted a heat map just to, like show the correlation among the features. And so the strongest is between strength and cement, which is zero point 0.5, which actually happens to be the highest. And so also like a distillation plot just like see the distribution of the values for like the strength. So the strength would actually be the target variable. And so for linear regression, the first thing was to set aside like the features. So that would be all the features minus strength, which would be like the target variable. And so y is actually a target variable. And then using the X train, I actually like split my data. So I'm using 75% for training purpose and 25% um, to test. And so this is what I actually have. And then next thing was to like initialize like linear regression. And then after like running it, so this is what I have. So the R score is showing 0.60, which is actually not that good. And then a plot of the predicted strength, which is actually on the x-axis, and the one from the test. So I mean, as you can see, the correlation is actually weak. So just to like tweak this further, I decided to like use lasso and ridge. And so for the lasso and ridge, the mean was 0.59. I mean, greater than yeah, which is almost like the same with what we had earlier. So there wasn't really like any improvement. And then the third one would be like the SVR model. So using the vector analysis, I was able to like just use the kernel RBF. And then for these, after like running it, as you can see, this actually gave me a R score of 0.86, root mean square error 6.17, and mean square error of like 38. So and I also like plotted a scatter plot just to like show plotting the predicted concrete strength from SVR from the vector analysis, like the actual um, test data. And so you can see like it's almost a straight line. And so this is so in conclusion, like of all the three models used for predicting the strength of the concrete mixture, like the SVR model actually showed gave us like a strong correlation with over 86%. And so that's yeah, so that will be yeah, just my first project using machine learning. Yeah, thank you.